How to study the classical laws of mechanics. This article describes briefly the laws of mechanics for physics students. Steps 1. Learn about Isaac Newton to begin with. Isaac Newton was an English scientist who formulated 3 laws of mechanics based on his observations of the nature of macroscopic objects with a mass m. He formulated 3 basic laws that continue to be valid until now in spite of the long time that has passed since its discovery. It is known nowadays that Newton's laws of mechanics apply only to macroscopic objects that are either at rest or are traveling at a speed much lower than the speed of light. 2. Learn about later discoveries and how they impacted Newton's theory. The discovery of the theory of relativity for systems that are traveling at speeds close to the speed of light and the formulation of the quantum theory of atomic particles and light did not cancel the theory of classical mechanics by Isaac Newton. The difference is in the systems these theories apply to. 3. Learn about what classic mechanics is applicable to in our modern world. Classical mechanics is still a valid theory of motion of macroscopic objects that is used particularly in many areas of life such as in car development and in airplane technology, as well as many other applications in the area of engineering. In addition, it is applied in the construction of bridges and various types of buildings. Also, classical laws of mechanics are still used in the physics calculations for spaceships that travel in the outer space, such as the calculation of the velocity that is required for a shuttle to escape the Earth gravitational force. Many other applications of Newton's laws are applicable, such as the technology of parachutes, which are used for making safe landing from high altitudes to the Earth's surface. The principle of action of a parachute relies on a differential equation that is called the Langevin equation. This equation includes terms that represent a frictional force that inhibits the free falling of the object from the sky. This is but one of many applications of these laws of mechanics. 4. Learn about Hamilton's and Lagrange's theories. 2 other scientists called Hamilton and Lagrange have both formulated 2 separate theories of mechanics that basically are other forms of the same laws by Newton that use different formalism. These concepts are used today in the area of mechanics that is called analytical mechanics. Hamilton and Lagrange formalisms of classical mechanics have analogous formalisms in the theory of quantum mechanics. Special operators in quantum mechanics bear the name of these scientists as Hamiltonian and Lagrangian operators. 5. Understand the first law of mechanics that was first put by Newton. It is nothing but the law of conservation of energy. This law states that energy cannot be created nor annihilated, but it can take different forms and can be interchanged mutually between the various energy forms. The forms of energy range from potential energy to kinetic energy to other forms such as heat and frictional energy. For example, potential energy can be converted into kinetic energy. The fact that energy is conserved in classical mechanics does not apply to mechanics in the relativistic domain of physics. In this domain, energy can be converted to mass. In addition, particles can be annihilated to photons of light and vice versa. The first law of mechanics of energy conservation has applications in thermodynamics, in which it is called the first law of thermodynamics. In terms of classical mechanics law, this law states that an object with a non-relativistic mass m that is traveling at a constant speed will continue to travel in the same speed unhampered as long as there is no external force that is acting on it. 6. Learn the second law of classical mechanics. It applies to accelerated systems which are under the effect of an external force. The formula that depicts this law is F equals ma, where F is the external force that is acting on the system and m is the mass of the object and a is its acceleration. An example of an application of this law in physics is the free falling of an object from a high altitude to the Earth's surface. In this case, this object will be accelerated in the amount of g and its speed will be increased gradually in an accelerated fashion. This happens because there is only one force that is acting on the falling object, which is the gravitational force. Circular motion is always considered a motion in an accelerated fashion due to the presence of a centrifugal force that acts on the circulating object and tends to force it out of the circle. 7. Learn the third law of classical mechanics. It can be described as an action and a reaction to it. A force in one direction that is operated on one object has always an opposing force in the opposite direction that is equal to it in value but of the opposite direction. One of the most important applications of this law is the science of rockets' propulsion. The propulsion of rockets is purely based on this law, in which combustion of fuel in the rocket leads to the production of force that leads to movement of the rocket system. The force that is generated by the produced gas is in the direction outside the rocket. An opposing force forces the rocket in the opposite direction. The net result is the propulsion of the rocket in the opposite direction to the released gas.